My dear friends, in previous 3 classes we have discussed about the electric charges, its properties. Then we have discussed in the class 2 the charging of a body or the electrification of a body. In class 3 we have discussed about the Coulomb's law of electrostatics. Now we will discuss in the class 4 we will discuss about the application of Coulomb's law and the principle of superposition, and on the basis of that how the numericals get solved. We will discuss today. According to Coulomb's law of electrostatics, force between 2 point charges Q1 and Q2 at a distance r in air is F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. In the previous class we have already derived this relation, and also we have discussed that if Q1 and Q2 with the 2 charges are placed at a distance r apart, then the electrostatic force in air is 1 by 4 pi epsilon 0 Q1 Q2 by R square. Clear? On the basis of that we can solve. In 2014 there is one question. 2 charges Q1 and Q2 are placed at a distance r in air. Experience a force F. 2 charges Q1 and Q2 are placed at a distance r in air. Experience a force F. Find the distance if same 2 charges are placed at a distance d in a medium of dielectric constant. Okay. Experience the same force F. Listen to me. 2 charges Q1 and Q2 are fixed. Here 2 charges Q1 and Q2 both are fixed. Clear? Are placed at a distance r. Let this Q1 and Q2 are placed at a distance r. Then electrostatic force in air F air, then F air is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. Okay? Q1 Q2 distance r is given. So according to this formula, force in air is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. Okay? Now, electrostatic force in a medium of dielectric constant, how much? K. It is given when I place in a dielectric medium of constant K given is F medium. Then F medium is equal to 1 by 4 pi epsilon 0 K Q1 Q2 by R square. Okay? Listen to me. Here given the force is F and this is force is also F. Explain the same force. Force is same. It is given. Here the force is F and here also force is F. Okay? So if these two forces are equal, I can write force in air is equal to force in medium, Only difference is here the distance is r and here the distance is x. Sorry. Let x, and I have to find out x. Then find x. Okay. So 1 by 4 pi epsilon 0 q1 q2 by r square is equal to 1 by 4 pi epsilon 0 k q1 q2 by x square, because these two forces are same, only distance is different. So 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0 cut out. q1 q2 again cancel each other. Now the conclusion is r square is equal to kx square, or I can find as x is equal to r by root over k. Clear? I hope this questions in 2014 CHS. Only there is a change in medium and a change in distance. Charge is same, force is same. Here force is constant and a charge is constant. So charge get cancelled and force is same. So they are equivalent. Clear? So we get it as x is equal to r by root over k. Similarly, a charge Q is divided into two parts. So that force between them is maximum for a fixed distance. Then find magnitude of each charge. A charge Q is divided into two parts, so that force between them is maximum for a fixed distance. Then find the magnitude of each charge. This is 2013 cancelled exam and also 2015. This question is there. So Q is divided into, let us imagine this is a charge Q and I have divided into two parts. Let one part is dq, then remaining part is q minus dq. Okay? And now I have to find out what is dq and what is q minus dq. Let I have taken this is q1 and this is q2. Let these are two charges of q1 and q2. Okay? Therefore, electrostatic force F is equal to 1 by 4 pi epsilon 0 q1 q2 by r square. It means q1 is dq and q2 is. So 1 by 4 pi epsilon 0, instead of q1 I can put dq and instead of q2 I can put q minus dq. Okay. So instead of q1 I have written dq and instead of q2 I have written q minus dq. Clear? It is given that force between them is maximum. To find out any force or any condition to be maximum or to be minimum, to find anything, if you find it, then it's a derivative with respect to this variable quantity. Here the variable quantity is dq. If dq increases, q minus dq decreases. If dq decreases, then q minus dq increases. It means the variable quantity is dq. So with respect to that physical quantity, the derivative must be 0. Or I can write it. If electrostatic force is maximum, then then the force with respect to variable quantity, then the dF by dq is equal to 0. Listen to me. Here 1 by 4 pi epsilon 0 is constant quantity. Here r square is also constant quantity. Only variable quantity is dq. So dF by dq means d by dq of 1 by 4 pi epsilon 0 dq into q minus dq. Listen to me. By r square must be 0. It means 1 by 4 pi epsilon 0. This is constant quantity. R square is also constant quantity. So they are taken out. The remaining quantity is d by dq of q dq minus dq square is equal to 0. So these are constant quantity, so are taken out. Only variable quantity is mentioned here. So this quantity when comes as a denominator, 0 by anything is 0. So only, so derivative of q dq, d by dq of q dq minus dq square is equal to 0. Clear? This. Here q is constant quantity. Q is divided into 2 parts, so q is constant. So I have taken q constant. So dq derivative with respect to dq is 1 dq square. As like as x square derivative is 2x. Similarly dq square derivative is 2 dq. Again dq derivative is 1 is equal to 0. Implies dq is equal to how much? 2 dq is equal to q. So dq is equal to how much? Q by 2. This is I have taken as q1. Okay. Therefore q2 is equal to q minus q2 is equal to q minus dq. So q dq means q by 2. The conclusion is q1 is equal to q2 is equal to q by 2. Find the magnitude of each charge, or it can be find out q1 is to q2 is equal to 1 is to 1, because both the charges are equal. Two charges are equal because each charge, if they are divided equally, then the electrostatic force between them is maximum. Very, very important questions. Regularly questions. Repeated questions. Okay. Next. Comparison between Coulombic force of electrostatic in the third class we have already explained that Coulombic force of electrostatic is completely analogous to Newton's law of gravitation. It means analogous. It means are they equal in all respect, or is there any difference? We'll discuss in detail. So whenever we are going to compare, we have to compare both the similarity and also its a difference. So similarity. What is similarities? First one, both forces obey Newton's third law. Newton's third law, that is F12 is equal to minus F1. How? Let this is a mass m and this is a mass m2. If this is the distance between r, then we have written F12 is equal to z m1 m2 by r21 q into r21 vector. Similarly, in case of charge, if this is charge q1 and this is charge q2, clear? This is r. Here, whenever we are moving from 1 to 2, the displacement vector is r21. Similarly, in case of also, whenever we are moving from 1 to 2, the displacement vector is r21 vector. Then, this is gravitational force and this is electrostatic force. Electrostatic force. Here, gravitational force. So, electrostatic force F12 vector is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R21 Q into R21 vector. Clear? It means both of it you can start that. Second. Both of it inverse square law. Inverse square law means F proportional to 1 by r square. If distance gradually increases, the force gradually decreases. Third, both are central force. Central force means they act from one body center to the another body center. From one body center to another body center. So they are called as central. Or it act along the line joining the two charges. If this is Q1 and this is Q2, then force act from this center of the discharge to the center of the discharge along that direction. So it is a central force. 4. Both are conservative force. Conservative force means the force is said to be conservative if work done by this force is independent of path. Path upar depend kariba nahi. It depends upon the initial point and depends upon the final point. It is independent. Or the scalar gradient of potential energy gives a vector quantity. Later on we will discuss on that. Whenever we are going to discuss about the potential, there we will discuss that whenever we are going to derivative the potential energy, you will find out a vector quantity. It means in which field the scalar gradient of potential energy gives a vector quantity, that is called conservative field. Or the force by which we did some work and that work is independent of path, then it is called conservative force. So both are conservative force. 5. Both occurs in air and free space. This force is also experienced, the gravitational force is also experienced in air, and also electrostatic force is also experienced in air. So these two forces are effective in air or free space. This is, we have discussed about the similarity. Now, electrostatic force. Now we will discuss about the difference. So electrostatic force is due to charges at rest. This force is F is equal to 1 by 4 pi epsilon 0 into K Q1 Q2 by R square. Clear? This is due to masses of the two bodies. I can write it as Fe and I can write it as a Fz is equal to Z m1 m2 by r square. It is both attractive or repulsive. It is only attractive. It depends on medium. Medium means dielectric constant F proportional to 1 by K. We have already discussed. Whenever there is a change in dielectric constant when get changed, the force also changes. Gradually, whenever dielectric constant of a medium gradually increases, then the force gradually decreases. It is independent of a medium. It is independent of medium. There is no dielectric constant in such cases. There is no. This is universal law. Very, very important. This is experimental force. But this is universal accepted. So this is universal law. Clear? Next. It is a strong force and short range force. Very, very important. It is a strong force but short range force. It is weak force, but it is weak force but wide range force. Clear? So this is the conceptual questions, that is comparison between Coulombic force and also Newton's force of gravitation. We have already discussed its similarities and also discussed about the difference also. Now the question arises, sir, this is a strong force and this is weak force. Sir, how can you justify this answer? Can we compare this? Yes, we can compare it. Let's see. Question. Compare between Coulombic force of electrostatic and Newton's force of gravitation of two electrons. Let us imagine this is an electron and also this is an electron. Okay? Separated by a distance r. So, gravitational force, I can write it as Fz, Z, m1, m2 by r square. Clear? So m1 is equal to m2 is equal to mass of electron and it is found to be 9.1 into 10 to the power minus 31 kg. Clear? Electrostatic force, I have taken it as a Fe. Let us imagine in air we have assumed 1 by 4 pi epsilon 0 Q1 Q2 by r square. Here we know that Q1 is equal to Q2 is equal to charge of electron. That charge of electron is found to be 1.6 into 10 to the power minus 19 Coulomb. You can put negative sign because electrons are negative in nature. Clear? If we found out this by this or Fz by Fe, we'll find Z m1 m2 by r square 1 by 4 pi epsilon 0 Q1 Q2 by r square, because here r is constant, because whenever you are going to Find the gravitational force. Same R is taken. If you are going to measure the electrostatic force, then same R is constant. So R is a constant factor. Clear? So I can cancel out this R square. I can put Z into ME square by 4 pi epsilon 0. I can put it as a beta or Coulomb constant Q1. The charge of electron E square. It is a constant quantity. It is a ratio. Very, very important. This questions regularly comes as a find out the dimension of this and this, where beta is the Coulomb constant. We will discuss later on. The value of Z, Fz by Fe. The value of Z is 6.67 into 10 to the power minus 11. Mass of electron 9.1 into 10 to the power minus 31. The Coulomb constant 1 by 4 pi epsilon 0. How much it is? 9 into 10 to the power 9. 9 into 10 to the power 9. E square means 1.6 into 10 to the power minus 19 square. Okay? If you solve it, minus 31, 31, 62, 62, 11, 51, 62, 73, 73, 38. Between two electrons. Fz by Fe is order is found to be 10 to the power minus 42. Approximately order is found to be 42. It is for electron. Hertz. Fz by Fe is order of 10 to the power 39 between electron and proton. Minus 39. Fz by Fe on to be 10 to the power minus 36 between two proton. Minus 36 indicates, or minus 36, minus 39, minus 42 indicates electrostatic force is stronger, gravitational force is weaker. It means gravitational force is 10 to the power 42 times weaker than 10 to the power 42 times weaker than electrostatic force between two electrons. 10 to the power 39 times weaker compared to electron and proton. 10 to the power 36 times electrostatic force is stronger than gravitational force between two protons. There are some questions are arising that find out the dimension of G square by beta Gn square by beta E square. Dimension of Gm square by beta E square, where G is gravitational constant, or we can write universal gravitational constant, and beta is Coulombic force constant. We know that this is nothing. Gm square by beta E square is equal to how much? Gravitational force by electrostatic force. That is force by force. Perfect ratio. No unit and no dimension. Clear? So we have already discussed about the application of Coulomb's law. We have already compared it with the gravitational force, and we proved that the Coulombic force is a short range force. It acts between 10 to the power minus, if the distance is more than 10 to the power minus 15, because inside 10 to the power minus 15 there will be another force known as nuclear force arises. So which is dominated, which is much stronger than electrostatic force. So electrostatic force is dominated. So it is effective when the distance is more than 1 Fermi and it is a very short range force. Because with increasing distance, the electrostatic force decreases. It is a wide range force, gravitational force is a wide range force. So this is the comparison. And out of that we have concluded that gravitational force is weaker and electrostatic force is stronger by 10 to the power 42 times between 2 electrons, 39 times between electron and proton, and 36 times between 2 proton. Very, very important concepts are there. The last part of the electric charge. Sometimes these dimensions are asking in some entrance questions also. Now we will discuss about the principle of superposition. What is principle of superposition? For a system of charges, let us imagine I have taken a number of charges and I would like to find out the net force acting on one particle due to other. Okay? The net, because force is a vector quantity, it may be positive, it may be negative depending upon the direction. So net force acts on a particle. That can be found out by using vector addition law, and that is called as principle of superposition. Let's see. Principle of superposition. For a system of charge of any distribution, net force acts on a particle is equals to vector sum of individual forces. Acting on it. On the basis of Coulomb's law of electrostatic is called principle of superposition. Listen to me, I would like to say that. Let us consider coordinate system. And this is Q0 particle. This is Q1 particle. This is Q2 particle. So R0 will be the position vector of Q0. Q1, R1 will be the position vector of Q1. Q2, R2 will be the position vector. In such a manner, we can find out the Q1 with the charge of another charge having position vector Rn. Now I would like to find out the net force on the charge Q0. So this is the Q0. Okay. Then this is R01 vector. If I will find out this net force on the Q0, that is R02 vector. This is R0n vector. In such a manner, I can take another particle, and now I would like to find out the net force. If Q0, Q1, Qn are the n number of charged particles having position vector R0, R1, Rn vector, then net force on the Q0 is equal to F01 vector, F02 vector or F0n vector. Clear? Or I can write it as a beta, where beta is the Coulombic force constant. Clear? So Q0 Q1 by R10Q into R10Q vector, because F01 means 10. Similarly, beta Q0 Qn by Rn0Q into Rn0 vector, or I can find out as the beta I is equal to 0, Ji greater than J, Qj Qi by listen to me. Here I have a total schematic I have written in the summation form. When J is equal to 0, I must be greater than J. I must be greater than J. So if J is equal to 0, it may be 1, 2, 3, 4, 5, 6 up to n. If we take 2 particles, then it is up to 1. If it is taken 3 particles, then it is up to 2, because we have started from 0. Then J is equal to 0, K 1, 0, 1, 0, 1, then 0, 2, then 0, 3, then 0, 4. In such a manner it will be occurs. So net force, if these two forces are opposite to each other, may be cancelled out. So depending upon their direction, it is treated as a vector sum. So vector sum of all the constituent vectors will be give the resultant, and this is called as the principle of superposition. Clear? So for a system of charge of any distribution, net force acting on a particle is equal to the vector sum of individual forces. Very, very important, because they are vector quantity. That's why it is a vector sum of individual forces. We'll do some problems related to it. Then three equal charges are placed at the three corners of a equilateral triangle. This is the equilateral triangle having side A. If the force between the two charges is F, if force between two charges is F, then find net force at each vertex. Actually, I have to write the full question, so for duration of time I have deducted it that if three equal charges are placed at three vertices of an equilateral triangle, three equal charges are placed at three vertices of an equilateral triangle of side A, and force between, and if a force between two charges is F, find the net force at each vertex. Listen to me. So it is a what type of triangle? Equilateral triangle means each angle. In case of equilateral triangle, three sides are equal, three angles are equal. So each angle must be 60 degrees. So force between two sides. So electrostatic force between two charges, how much? F side is equal to F given, and F side is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. Okay. it means 1 by 4 pi epsilon 0 q square by here q1 is equal to q2 is equal to q3 is equal to q3 charges are equal and r is equal to a. Okay, it is given as a f. Clear? Now the question, find the net force at each vertex. Like this is one force and this is one force. So how many forces are there? This is also f side. This is also f side. If this angle is 60, then this angle is also 60. So net force, I want to find the net force is how much. This is the questions you have put. Clear? Listen to me. According to vector addition law, how much? F net is equal to f1 square, f2 square, 2f1 f2 cos theta. As like as parallelogram law, r square is equal to a square plus b square plus 2ab cos theta root over. Parallelogram law, vector addition, we have discussed it in 11th. Now f1 and f2 both are f side, so and f side is equal to I have taken f4, so f square 2f into f. The angle between the two forces is how much? Cos 60. So cos 60 is half. These two cancel out, so the answer is 3f square or root 3f. Clear? Did you get it or not? How many forces are there? Two forces are there, and these two forces are vector quantity. So if as they are vector quantity, they should be found out by using vector addition law, and by using vector addition law we have found out the net vector. Clear? So I have used here only vector addition law, parallelogram law, vector addition law I have used it. As r is equal to a square plus b square plus 2ab cos theta. Instead of a, I have put it f1, f2, but both f1 and f2 are the two sides of a vector, two forces at two sides, and f side is also, find f, it is given, f given, that's why instead of f1 and f2 I have put it f. So f square plus f square, these two cancelled with these two, so again f square, 3f square. So 3f square, whenever we have taken the root, it is found to be root 3f. Okay? Next. In this case, I have taken a square. Let each side of a square is A, and 4 equal sides are placed at 4 vertices. Q. If 4 equal charges are placed at each vertex of a square of side A and force between two charges find net force at each vertex. If 4 equal charges are placed, I have taken 4 equal charges and 4 vertices of a Q and side is A. Let us say this is Q, this is Q. It means this is force due to side. This is force due to side. So how much is force due to side? So electrostatic force due to two charges at the side. So I can find it as a Fs is equal to beta. This is Coulomb constant. Q1, Q2 by R square, and it is formed to be beta Q square by the side is A. So this is F side. Equation number 1. Now listen to me. If these two are the charges at the side, these two are the charges at the side. If this is the force Fs, this is the force Fs, there is another force. That is, I can write it as a Fd. The two charges due to diagonal. Electrostatic force due to two charges at a diagonal is Fd. How much? Beta Q1 Q2 by R square. If it is A, then it is how much? Root 2A. Beta Q square by root 2A square is equal to beta Q square by 2A square, or I can find it as a Fs by 2, equation number. The question is then find the net force at each vertex. So hence I have to find it the net force at each vertex. So net force according to principle of superposition, this is net force. How much? F vector is equal to F side vector, F diagonal vector. Listen to me. How many forces are there? Due to these two charge, force is this. Due to these two charge, force is this. Due to these two charge, force is this. So how many forces are there? 3 forces are there. So I have written 3 forces. Listen, Fs vector and Fs vector. These two Fs vectors, side vectors, are perpendicular to each other. These two forces are perpendicular to each other. We know that if two forces are perpendicular to each other, the resultant is angle is 90 degree. So using again vector addition law, if you use the vector addition law, then F vector is equal to F1 square, F2 square, 2F1, F2 cos theta. These two vectors are 90 cos theta 0. So F1 square, F2 square. So F is equal to how much? F1 square, F2 square, root over. Clear? But here F1 and F2 both are, as F1 is equal to F2 is equal to force side. These two forces are equal. Okay. So these two forces are equal, or I can put Fs square, 2Fs square means root 2 Fs. How? The resultant of these two vector. So instead of this, I can write it 2Fs. If the resultant will be along that direction and force due to diagonal is also along that direction, so let the resultant of this is let F dash vector. So these two resultant is F dash vector due to force side, or I can write it here also. F dash vector is equal to Fs vector plus Fs vector. These two Fs vector when superimpose F dash vector. So F dash vector is found to be root 2 Fs plus Fd, because both are in the same direction. So root 2 Fs, Fd means Fs by 2 means Fs when we are taken common, root 2 plus 1 by 2 or 2 root 2 plus 1 by 2 Fs, 2 root 2 plus 1 by 2 Fs means we have find out beta 1 by 4 pi epsilon 0 q square by a square. That is net force. And directed along the diagonal. Okay. Today we have discussed a little bit about the principle of superposition. In detail we will discuss. Lots of things are there. We will discuss later on. This finishes electric charge. So these 4 classes combinedly finishes your first chapter, that is electric charge. In the next class we will discuss about the electric field. Thanks to one and all. Thanks for watching. Thanks.